So now we're going to study resonance effect. So when we look at the benzene ring, for example, uh, it's like this, right? C, and this comes out of the plane like that, and this goes into the plane. This goes out the plane. You have a p orbital with one electron, which should be showing some kind of the partial double bond character, something like that. So delocalization of pi electrons in a conjugated system is called resonance. One of the conditions for it to show resonance is minimum 3p orbitals line up in the same plane. Like this is 1p, 1p, all in one same plane, right? See, now you look at this benzene example over here. You see one is like this, others like this. And so we make a hybrid like this, showing partial double bond character all over the ring. Now, if you look at direction of resonance, which is also known as the mesomeric effect, which tells us the direction of the resonance. As you can see in the first example, CH2 is a double bond CH, then CH2 is a carbocation there, right? So here we break this, giving plus over here and minus over here. This minus plus forms a double bond. We'll talk about the direction over here in more details later on. Now CH, you see the same way. Now we can do it with p orbitals, same thing. Now if you look at the resonance hybrid over here, you see the partial double bond here, and there's a partial positive charge also. Now this is an important concept which I've highlighted over here, this and this. So for first one, we know N doesn't have a d orbital, so it can't expand its octet. So double bond NH3 means 5 valence means 10 electrons, which is not possible, so it can't resonate over here. Now if we look at chlorine, and let's say the Cl left. Now if we look at this plus charge will be this plane, whereas P will be in that plane. So there's no backup from resonance. Hence, it's unstable. Now, looking at resonance in anions, the CH2 minus will attack here. This double bond will shift, giving plus to this, which makes a double bond over here, and there's a minus which comes here. And you can see the resonance hybrid as a delta minus, and this partial double bond character. You can also look at the diagram over here. Now, talking about direction of resonance, which is nothing but the mesomeric effect, right? Here, if you look, see, we are shifting the double bond, and we're going C plus H2. So this is minus M, right? Where we're going towards the plus charge. Over here, the minus is giving. Minus and known by the same action which is going on over here. It's giving electron. So that is plus M. Taking is minus M. Let's look at this example here where this is an alpha carbon, right? This is an alpha, this is a beta carbon, this is beta, this is alpha. And this is a nucleophile, meaning it's an electron rich species. And this is an electrophile, which is electron deficient species. Now if we look at it and we form a carbocation over here by shifting double bond on the beta carbon and we resonate it, we find we have 6 resonance structures. Whereas if we did in alpha, we have 7 resonance structures, which says it's more stable as there's more resonating structures. Now, look at benzene with an OH and we remove the H, you get O minus. Now if we resonate this, there's something we can see here is the negative charge moves around in the ortho, para and ortho over here direction. The same as it lone pair. Now if it was an electron withdrawing out, the positive charge will be rotating in ortho para, right? Now look at the free radical mechanism. We break the double bond here and give one electron over here, as you can see, and these two over here will form a bond like this. Okay, that's enough for resonance. One thing you can make sure from this over here, this point which is important. So minus charge, we are going ortho, para, ortho. So if you put a group which, let's say, which can donate has a lone pair, or let's say NH2, let's put here, this has a lone pair, so, and there's a minus charge, I imagine, so it's not going to stabilize it, right? But if you put NO2, that is going to stabilize it. So you can solve questions like this. It's like same as plus I minus I group. When you're putting, is it electron withdrawing, electron donating, we can check like that.